Hello students, this is a project called Digital Learning. This video is a part of Digital Learning project, which is a brainchild of Department of Collegiate Education. So in this video, I'll be discussing about a part of the BSc third semester syllabus. The chapter name is DC Circuit Analysis. This video is presented by Savita S. So in this video we'll be discussing about basic parts of the network analysis. So the content consists of commonly used terms in circuit analysis, concept of voltage source, concept of current source. So commonly used terms in circuit analysis, branch. So there are certain things that we commonly use in the study of circuit analysis or network analysis. So we keep coming across these words. So we'll have a brush up of the meaning of these words. Branch. A section of the network along which the current remains constant is called branch. Node. A node is a point where two or more branches meet. Node is also called as junction. Mesh. Mesh is a closed conducting path made up of several branches. A closed path for the current is called as mesh. It's also called as loop. Network. Combination of all this. A network will have a branch, node, meshes, several nodes. Network is a systematic interconnection of electrical elements and sources. So in network we have different types. We will be concentrating on linear and bilateral network in the present chapter. So a linear network is one in which the circuit parameters, that is resistance, capacitance, inductance, are constant with respect to current and voltage. That means the value of resistance will not change with as the current changes, or if the voltage changes, capacitance will not change. So these are the parameters which remain constant. Bilateral network. A network whose behavior remains the same regardless of the direction of the current through its various components. That means if the direction of the current is reversed, there is no change in the behavior of the circuit. So this figure gives an idea about node, mesh and this branch concept. So in this network we have several nodes, meshes and also branches. So for example, this AB is a branch. So branching is, we say, whenever the current divides. So for example, here we have a battery, a source which supplies the current, which gets divided after reaching the point A. So A is a node where battery and two resistances are meeting. So this point is called as a junction. So the current that is coming from the battery has two paths here. It can either go through R2 or through R1. So the division of the current is called as branching. So R2 is one branch, R2 parts a part of the branch, and R1 is another branch. So A is a junction where the two branches are meeting. So B is another junction where you have three resistances meeting, R2, R3 and R4. So the current that is coming towards B gets divided between R3 and R4. So C is like that. C is another junction. G is the ground point and we have a source here. So AB is a branch, BC is a branch, BG is a branch, AC is also a branch. So B is a junction or a node. So this closed path ABCA, ABGA is called as mesh. So this is another closed path BCGB. This is another mesh. So here we have one more mesh. The closed path for the current is called as mesh or a loop. So we have three loops in the network. So any electrical network will have source. So sources are of two types, voltage source and current source. So voltage source means battery, DC battery. In this DC circuit analysis, we discuss only about DC sources, direct current source, direct sources. So a device which produces a constant voltage output is called as a direct voltage source. So this is called as a circuit diagram, in which we have shown a source, and the source usually will have some resistance called as internal resistance, which is shown explicitly here as Ri, and generally there will be an external load resistance, RL. RL is called as load resistance. Ri is the internal resistance of the source, that is the battery. Battery's internal resistance is represented as Ri. So internal resistance means the opposition to the current inside the source. So current flows whenever there is a closed path. So current, the conventional direction of current is from positive of the battery to the negative of the battery through the external resistance. So the source containing negligible internal resistance is called as an ideal voltage source. So in an ideal voltage source, voltage is constant. Suppose you vary the external load resistance here. What happens? If you increase the resistance, current decreases. Current decreases, but voltage will not change. So whatever is the external load, voltage should remain constant. That is in case of an ideal source. But practically sources will have some internal resistance, very small internal resistance. So there will be a drop across small internal resistance. Hence the output voltage will not be strictly constant like this. It will be slightly decreasing. As the resistance changes, current through the resistance will slightly change because of the internal resistance. There is a drop across Ri, the drop across RL. So if RL changes, drop across RL will change. So the current slightly changes. Voltage changes. Voltage will not be strictly constant in case of practical source, whereas voltage is constant in case of ideal source. So current source. A current source supplies a constant current through the circuit. So as we have seen in the earlier case, voltage source supplies constant voltage. Like that, current source supplies constant current no matter what the external resistance is. So here we have not shown the external resistance. These are the two output terminals. We can put an external resistance here. So if you change the resistance also, current will not change. So a current source supplies a constant current through the circuit. It consists of a power source with a finite high resistance in parallel to the source. Small r is the high resistance connected in parallel with the source. So current source is represented by a line with an arrow representing the direction of the current. So ideal current source has infinite parallel resistance. So current will be strictly constant in case of an ideal finite source. So wherever constant current is required, for example, to control the speed of DC motors, we need constant current. So in such cases, current source is used rather than the voltage source. So these are some of the basic things that are required for understanding network theorems or network analysis. So we will discuss more about the network theorems and other things in the future videos. Thank you.